In section 2.6, we're going to write ratios and proportions. Key vocabulary, you're going to need a ratio. If you remember our definition of a rational number, it's a ratio of two integers. So inherently a ratio is a fraction. And a proportion involves two ratios that are equal to each other. So we use proportions in order to solve for unknown values. And then in simplest form, we're really talking about how do we simplify fractions. Okay, so we'll go through that vocabulary as we go along. We want to review algebraic properties of equality. We have A, B, and C that are real numbers. The addition property of equality says that if A is equal to B, then A plus C is equal to B plus C, meaning I can add the same value to equal things and they stay equal. The subtraction property is the same, only we're talking now about subtracting. So if two items are equal, I can subtract the same value from either of them. I can multiply either of them by the same number. I can divide either of them by the same number. And also if A is equal to B, then I can substitute A for B in any equation or expression I'm working on. Okay, so these are all review of things we've already been working on. And if we look at a ratio uses division to compare two quantities. And I can write ratios of two quantities, A and B, in three different ways. I can say it's the A to B with the word. I can do A colon B, so the ratio of A to B is also read A to B. And also A divided by B, which as a ratio is also read as A to B. And you always want to write ratios in the simplest form, meaning if there are common factors in the numerator or the denominator or to the right and left side, I would want to eliminate the common factors to put the item in its simplest form. So if we look at writing a ratio, a volleyball team plays 14 matches, home matches, and 10 away matches. Find the ratio of home matches to away matches. Well, that would be 14 to 10, or 14 over 10, but this is not in simplest form. Both of these are divisible by 2. It really should be 7 to 5, right? Or 7 over 5. That's the A part here. And in B, the ratio of home matches to all matches, there are 14 home matches, and all matches there are 24. 14 to 24, or as a fraction, 14 over 24, sorry, 24. And these also can be simplified. This becomes 7 to 12. Okay, so that's what we're talking about in terms of creating the ratio and also expressing it in simplest form. Okay, if we want to work on a proportion is two ratios that are equivalent to each other. And what we're going to do in this case is find the cross product. So we've learned hopefully you've learned to cross multiply. And what we're actually doing when we do this, I'd like to be kind of explicit. I know that the cross product is 100D is equal to 5 times 80, which is 400. But let's talk about what we're doing when we find the cross product. What we have here is we have a value of 5 and 100 as denominators. And if you look at what is our least common denominator, it's 100 because 5 goes into 100. If I multiply both sides of my equation, what's going to happen here is when I multiply, I multiply the 100 times d over 5. 5 goes into 100 and leaves 20, so it's 20 times d. I'll get 20d. And then the 100 will cancel with the 100 when I multiply it over here, and it'll be equal to 80, and d is equal to 4. And over here, I'll divide by 100, and d is equal to 4. When we multiply and find a cross product in a proportion, what we're really doing is we're multiplying both sides of the equation by the least common denominator, which is, by the way to get rid of all the fractions in any equation at any time. So I just want to make sure that you understand that's what's going on. It's totally okay to do this. It's the same as multiplying both sides of the equation by 100 and then multiplying both sides of the equation by 5. It's exactly the same. It's just combined into a single step. Okay, so either way you want to do it, we both come out with the same solution. They're both correct. So if we look at a different proportion, t is to 21, t is to 21, as 40 is to 28. And again, we can go ahead and cross multiply of 21, but times 40, I could do that, but does seem like it would be a lot easier if I simplified this first, right? So I can see that 4 goes into each of these values, right? So then this will be 10, and this will be 7, and now what I'm going to multiply is 21 times 10, that's a lot easier than 21 times 40, is equal to 7t. Right, and actually when you look at it, you can see that I can divide both sides here by 7. 7 goes into 21 3 times. 3 times 10 is 30. T is equal to 30. Okay, so when we're working on simplifying, we don't have to dutifully do things like multiply 21 times 10. If there's another way that we can keep simplifying, we always want to simplify before you multiply. So in this case, I simplified the fraction first, and then I also looked at simplifying over here before I went ahead and multiplied, just to make the math as easy as possible. So when we're looking at proportions, there are always different ways to set proportions up. I can set the proportion up based on, as long as I keep like relationships in like places in the proportion, I can set the proportion up always a couple of different ways. So we've got here setups where we're comparing tomatoes and pints to smaller recipe, normal recipe, and another way to arrange it is this way, where we're comparing smaller recipe, normal recipe to tomato and pints, right? And it puts things in slightly different places. And what you can see here is that when I make a proportion for tomatoes, smaller recipe to normal recipe, and number of pints, smaller recipe to normal recipe, I come up with this proportion. But you can see I'm always relating like things to like things, tomatoes to tomatoes, pints to pints. That's great. And then when I cross multiply, I'll get 12x is equal to 4 times 30, which is 120. When I arrange this the other way, we look at, now we're organized by the recipe. So now I'm taking the items in the smaller recipe and relating tomatoes to pints, and items in the normal recipe relating tomatoes to pints. And you can see tomatoes are always in the numerator here, pints are in the denominator. And when I cross multiply to get the cross product, I get 12x is equal to 4 times 30, so it's 120. And you see the results are the same. Okay, so it doesn't matter how you organize it. What matters is that you always maintain the relationship of what's in the numerator and what's in the denominator, right? In each case, x will be equal to 10. Okay? So hopefully you'll get the sense that don't stress too much over how you organize it. It isn't that one way's right and one way's wrong. They're just two different ways to go about it. And finally, let's work on this problem. An elevator takes passengers from the lobby of the John Hancock Center in Chicago to the observation level. It travels as 150 feet in 5 seconds. Okay, great. So we're talking about feet in seconds. The observation level is located on the 94th floor, 1,029 feet above the ground. Find the time it takes the elevator to travel from the lobby to the observation level. Okay, well, a traditional way to put this together is speed is related as feet per second. So if I put it together as 150 feet in 5 seconds, that's the way I would calculate its speed. And then if I've got feet in the numerator, seconds in the denominator, I know I would go 1,029 feet in x seconds. Okay, that's a way to go about it. And then if I solve that proportion, I'll get 150x is equal to 5 times 1,029. You can see again I can divide both sides by 5, so 5 goes into 150 30 times. So x would be equal to 1,029 divided by 30. Okay, I'm not going to go ahead and finish getting the decimal that relates to that. But what I do want to talk to you about is sometimes it's awkward when you create this ratio if you put the variable you're looking to solve for there in the denominator. That can be kind of difficult. It's just as valid for me to take this ratio and make it 5 seconds over 150 feet is equal to x seconds over 1,029 feet. Okay, and you'll generally find that it's easier if you put the variable in the numerator, simply because if you look at my continuing on with this, I know that the 5 will go into the 150 30 times. That's nice. I could have done that here too, and I did it in the second step. I could have done it in the first step. And so I'll get 1 over 30 is equal to x over 1,029. And if I multiply both sides of the equation by 1,029, you'll see I get 1,029 over 30 is equal to x. That was the value of having this in the numerator. So you'll notice I didn't get the cross product this time. Instead, I simplified the left side and multiplied both sides of the equation by the denominator under the variable. And I come up with the same answer. Okay, so again, it isn't that one is right and one is wrong. What's important is that you follow the rules of mathematics that we're learning here, and you work the equation in the way that's going to give you the best chance of being successful. That's it for section 2.6.